Hello, everyone, and welcome to meeting number 85 of the Ethereum All Core Developer Call. I'm Hudson, and we're going to start with the first item on the agenda. It is the Berlin EIPs that are confirmed, getting implementation updates from the clients, and seeing if there are any issues anyone's having so far with that. So first, I'll pass it over to James to run over to go over the Berlin EIPs.
The ones that we've talked about so far are EIP 2315, simple subroutines for the EVM, and EIP 2537, which is the BLS curve operations. Ones that are tentatively that may or may not be included are the 2515 difficulty bomb and 2456 time-based upgrades. So let's start with 2315. Is there any updates? Or
it's been not updated semantically or content-wise, but test cases. Yes, there was some bug in the Go implementation, how the opcodes were defined. That's been fixed, and the test cases have been updated, and I've amended with one more test case. Yeah, implementation wise, I've seen that there was a startup in implementation in parity. I think there's a new one brewing, and we will get started on making the EAP test cases into actual state tests based on the Get implementation. That's it, I think. I don't know if Parity has anything to add about their implementation there.
The pull request in Open Ethereum is up, so it's currently under review, but hopefully it should be in soon.
Cool, thanks.
You mentioned adding a test case. Were the test cases not sufficient in the EAP? Was there like some corner case, or was it more of a misreading of the EAP?
No, it was just a clarification. I try to add test cases for everything that can be a bit quirky. And one of the quirky cases is that, hold on a minute, sorry. One of the cases is that you might have a routine at the end of the code segment. And when you do return from that subroutine, it should continue after where it left off, which is outside the range of the actual code. That's why I added that test case.
So are those things that should be added to the EIP itself, or do they just need to be?
Yeah, I already added them to the EIP itself. Just a clarification. So yeah, nothing really changed in the EIP recently. Just clarifications.
And then there's a parity and a Geth somewhat implementation.
Yes.
Okay. Is there anything from Besu?
Yeah, we also have an implementation. The PR is up, still under review, I think. So we should probably have it by the next core devs call. It should be pretty final.
Great. And as we're transitioning from talking about developing the EIP to implementing it, we previously had updates, like Berlin updates have been from authors about the EIP itself. But moving forward, I'd like to get updates, like go through the Berlin EIPs, but get updates from the clients on the status. So I kind of expect that those questions that'll be on the agenda for the next few calls until we're ready to deploy. Is Nethermind here? Thomas? Yeah.
Do you need an update on the 2.5 right? So we didn't start implementation, but I don't expect any troubles with this one.
Okay, that's great. We can moving on to, is there other things someone would want to bring up on that topic, or I'll move on to the next EIP? Okay, so for 2537 is the BLS curve operations. Who do we have on the call for representing that? Or what is the status of implementation for that? I guess Alex is here.
Well, I can, as far as I know, at least Dano has asked me to refer him to the reference implementation. It's complete and it's updated to the latest spec, which was changed due to general sentiments that's kind of one precompile should be made into two for clarity perspective. It also was updated to reflect that IETF draft was changed recently, but reference implementation and Go implementation by Honor, they both follow the new spec, so it can be just taken and integrated.
Sorry, I have a question here. So the reference, the IETF spec was changed, Is that correct?
Yes, IETF spec, well, it's a separate document and IETF work on them without asking anyone. It was changed. They changed the suggestion how to, what to treat as a sign of field element, because there is a selection rule for square roots and you have to select one of those. It was changed. It became much simpler, and so, but it would change the output of the function, obviously. So the code was updated to this new version of the spec.
And how does that relate to the existing stuff in ETH 2.0? Does it relate at all?
As far as I know and see in the discussion, it's not a problem for ETH 2.0 because it will be, they were based on even much more previous and outdated spec. So for them, even the previous versions of the spec would be breaking changes. So it's not a problem for them, as far as I know. Maybe if there is someone else here, they can answer it, but I'm not in ETH 2.0 directly. But it's at least what I know right now.
The one thing I think we should maybe talk about is this split into two EAPs. It was proposed by Dano. Axic was a bit against it. I don't really know. I defer to Alex Stokes. But I guess it makes sense to officially decide how to go about that.
What do you mean to changing it into two EAPs?
Well, didn't
yeah.
you split the curve operations into two separate ones, one for G1 and one for G2?
Well, just following the discussion in a pull request, I changed the mapping function, which before the change could take either 64 or 128 bytes and output also different lengths. I changed it to be explicitly two separate precompiles, one taking 128 bytes and 100 and another one taking 64. Yeah, it was a change that it's else implemented. So right now, public interfaces implementations follow it.
So I just thought maybe they weren't on that discussion. So maybe we should just decide in this forum if that was a good thing or not. Because Dana wanted it, Axic was a bit against it. I didn't really know, and yeah, I'm just curious to hear if there are people who have opinions about it.
Maybe I should clarify that the general sentiment from Axic was to not even, well, right now it's 9 separate precompiles. Sentiment from Axic was that it should be collapsed into one with another binary interface. Sentiment from Dana was just that previously it was 8, that one should be separated. So it's kind of either we have separate functions or we have one with much more complicated binary interface. Because before it, I think people wanted to have as simple precompile calls as possible. So one call to one function and no internal routing. I changed it to separate ones, but it's up to discussion. But I think previously the sentiment was also to split it as much as possible.
Yeah, in my comment, I made it clear that would be the ideal case for me, but I know that the sentiment was really in favor of having separate precompiles. So I don't really have any hopes that it would be collapsed into one. I just didn't want it to, never bring it up. But I know that this given BLS precompile in its current form is an exact result of the same discussion, that it was one complex precompile and it was split into separate precompiles. So I don't think my comment would be taken into consideration anyway.
Right, I thought your comment referred to only the most recent split, but then I was wrong.
Do you want I'm thinking about do you want to say what your reasoning is for that, Alex, so we can just have that as part of the record? Oh,
Another Alex.
Axic, Alex Borgasasi.
So it's coming from a developer experience point of view. So for the original 4 precompiles, all the which is SHA-256, RIPE, MD, EC recover, and the identity, those were supported by all the languages through language constructs, but any newer precompile wasn't. And every case when somebody is making use of those precompiles, they're implementing their own way of passing data. And the same is going to happen with these 9 or 10 precompiles. We have seen one example of that done in the deposit proxy and the complexity introduced there. And my reasoning is that we already have this well understood ABI encoding used throughout the system. And I think it would be really nice to make use of that ABI encoding for the precompiles, because then you wouldn't need native language support, but you could, native specific language support for new precompiles. You could just rely on the standard ABI encoding to interact with precompiles. And the reasoning, this was brought up previously, maybe even a few times previously. And the reasoning against using the ABI encoding was that it's supposedly ambiguous, but I think it can be made. The ABI, the encoding logic is strict, but the decoding logic isn't. But we can make the encoding here quite strict. So I think this reasoning wouldn't stand. But I guess so I also made a comment there that even if we have multiple precompiles, I would still prefer to use a version of the ABI encoding for the same reason. But the last reason I mentioned why it could be useful to have a single precompile is looking into the future when maybe these precompiles won't be precompiles anymore, rather they're going to be contracts. And in that case, because there's such an overlapping functionality between at least some of these new precompiles, then you would duplicate all of them into new contracts. But this reasoning is probably too far-fetched, and it shouldn't really be taken into account. But the other reasoning about using the ABI encoding, I think that's a valid one.
Is the ABI encoding something that could, at this point, I think it would be hard to go back and be able to meet the ETH2 stuff to get done. So just from a practical perspective, going backwards, I don't think is really a good way right now. But is an ABI encoding something that could be resolved later, or have like a ABI encoding for these pre-compiles that developers could use for a better experience?
There can always be implemented a reference normal API and do all the internal packing just all by itself.
As from my memory, Martin, the primary reason to split them is for security and reducing surface area for vulnerabilities. So maybe the middle in between is to have the precompiles and the ABI.
Yeah.
I don't know.
I haven't particularly looked at the actual format of the inputs to these precompiles, and yeah, I don't have any. I think it sounds okay to use ABI as input format, but yeah. I also think that we should keep them in the current form as separate precompiles, though. I'm not doing changes there.
Okay, so we should add a note to, or maybe Alex, Axic, you and I could talk about getting something about the ABIs to be more for. What did you say? Like the inputs need to be more strict.
I mean, it is possible to specify a really strict version of rules while still being capable of using the ABI encoding as it is. But actually, just one comment going back to the original question, which was whether the precompile for, was it like mapping? Well, anyway, the question was whether it should be a single one where it determines the operation based on the input length, or there should be two, and each of them expect a specific input length. And I think with the ABI encoding, those should be also separate, because it makes the ABI encoding also more clear. So probably my preference would be also to separate them.
Good, then I think we're in agreement about that.
Great. Is there any other thoughts on this from the group? Alex Vlasov, as far as spec and implementation and stuff like that, how is kind of timeline or the amount of work that is, like, how finished is it versus not finished? Could you spend just a second to give an update about that? This is in context
Well,
of trying to schedule.
Yeah, well, I mean, as I mentioned, as far as I know, right now there are two full implementations which were done specifically for this precompile and kind of a legacy from 1962, and those are in Rust, which I did, and another one in Go, which was done by Honor and Site. As far as I know, Go implementation done by Honor, it's now also conforms to updated spec. So in this sense, those are complete. I also started fuzzy testing the Rust code. For now, it's only being tested separately. So just to find internal bugs with a lot of internal protections disabled. So far, for like a day already, I didn't catch any crashes. Later, I will continue to cross-test one versus another. But at the moment, I would say those are ready to be integrated.
So what's left to be done is, I guess, another question.
Okay, well, what's left to be done is just cross-test them against each other.
Well, integrating as
just
well.
by fuzzy testing. Well, I mean, without integration, yeah, it's fuzzy testing. For integration, it's not to me, it's to client developers. And I can.
So cross tests need to be finished before integration starts, or is that something that can be started?
Answer for them.
Can be started. I think my
no, integration can be started already. Yeah, integration can be started already. Fuzzy testing will continue anyway, kind of separately in parallel. And in any case, fuzzy testing will not affect the binary interface and gas price.
You're cutting out a bit, Alex Vlasov, but I think we got the idea.
Yeah. I thought that was my internet, so it's good. Thanks for letting me know, Hudson. So perhaps we leave next meeting to get an update from clients on plans for integration, or is that something we should talk about now? Tim, you have something to say?
I mean, for Besu, we've already started to look at it, like how we can integrate the Matter Labs library as part of Besu, and it's still a work in progress, but it seems like it shouldn't be too complicated. And in the next couple of weeks, we should have we should have it in.
Okay, great.
Yeah, from the Geth perspective, I don't think anyone has done any work on it.
Nethermind?
Not expecting any issues.
And then Open Ethereum.
I think we had a pull request to merge 1962, but I think was Alex, and it was closed today, is not merged by the author. I didn't really look why, but other than that, we have no progress here.
I see. Yeah, well, I did close a pull request for 1962 as it's not going to be integrated. I didn't perform any integration with parity for 2557. So it's ideally I would appreciate if Open Ethereum developers can just do it themselves, taking into account that it's native Rust library and it's just easy one to feed the inputs to the functions, which just take bytes and output bytes.
Great. I think that's good for that EIP. Is there anything else someone would like to bring up on the BLS precompile EIP? So the next one, so those are ones that we've already decided as going into Berlin, and so yep.
I was gonna say real quick, I think I want to go ahead, if you don't mind, James, and skip to the quilt item, just because they have to leave in half an hour, and once we get rolling on the EFI, it'll probably just keep rolling.
Yep, good
So,
call.
yeah, so Quilt Team, just take a minute or two and explain what you guys are doing to get everyone up to speed.
Yeah, cool. Yeah, this should be pretty quick. So we included a link to our implementation rationale doc, which goes through some of the benefits of a minimum implementation of account abstraction. So this was originally suggested on the Ethereum Magicians forum by Vitalik. So we are moving forward on doing implementation on that in Geth. There are a couple research items that we still need to figure out, but most of the main questions are already answered for this minimal implementation, at least. So we are going to move forward on that, and we'll kind of keep you guys up to date, the data that we get, everything there, and we'll eventually go through the formal EIP process. A couple of things to keep in mind. So Quilt has largely been working on execution environments and a lot of things under ETH2 phase 2. We're focusing some of our efforts on this right now, as it's a kind of a strong way to iterate on some of those things we want in the long term for this kind of merged ETH1, ETH2 ecosystem. And account abstraction, some of the other things that we link in the doc, SSA, and other pieces are like a natural iteration value that can be added right now to kind of get to those steps. So yeah, there's 4 of us. We'll keep you guys up to date on what we're doing. I just say go through that doc, and if you guys have any questions, just ping any of us on the Quilt team. Yeah.
All right, thanks so much. Anybody have any quick questions about that?
This is for getting account abstractions into ETH1, so like pre-ETH2 implementation.
Yeah, for now we're focusing on ETH1, and then we have in that document we have some discussion on then what we do then to begin bridging some of this to ETH2.
Oh, that's great.
But yeah, first step is on ETH1.
I'm very happy to hear that this is moving forward, and I'm sure Mariano is going to be happy about it too.
Sweet.
All right, and then yeah, we can move on to EFI now. Where's the agenda? We can go back and forth on this. I can do the first one, you do second, I do third, because you do first one because that's yours, isn't it?
Well, you moderate it, but I can talk about it.
Sure. So first one is EIP 2515 for the difficulty bomb. EIP related to Berlin. So I think that's James, right? Is that the one
Yes.
you did? Okay, yeah. So
Yep.
you can go right ahead.
Okay, let me get I updated the terminology. The feedback that I got last time, I talked about this in February and January, and then we haven't really talked about it since on the call. So I'll give a general overview and find the link for the updated. I think that's in the, can someone grab the link that I put in the All Core Devs chat and then put that into the, thank you, Tim. So the idea is to do pretty much the same thing that the difficulty bomb has done, except for say that it will start on a specific block. So you, in a X number of blocks in the future, you say at that point, freeze the difficulty and then increase by 0.001% each block perpetually. So you get that, you get the effect of the difficulty increasing block times and making the, and doing all the same things that the difficulty bomb has done. We just know exactly when it will happen. The updated design was having that linear increase happen instead of it just freezing, which is a better design. So I've updated the EIP to have that information. The last one thing to confirm is it something that the group wants, and then is that, and if it is it something that can be done in time for Berlin? And the current open question is, do the increase function of difficulty, should it be linear, like purely linear, or is 0.01 0 like 1,000th of a percent sufficient? Or from like which of those are preferenced? So going back to the group on general sentiments and stuff, I did a lot of polling and talking to people on Twitter about it, and so I've since reduced it to being what it is now. So feedback on the design or
I
changes.
think, James, that the linear growth is a bit dangerous because it's disconnected from the actual hash rate growth, and it's potentially being exposed to miners reassigning a lot of mining power and speeding up the block creation, which is against really the idea of the difficulty bomb. I was thinking about the solution. I mentioned it once to you about changing the target block time instead of changing the difficulty, because one of the parameters of the difficulty calculation is the one that points us more or less at how often the blocks should be created. So I was suggesting to grow this parameter, and then we know that the whole thing will behave as it should behave. So it will be automatically adjusting the block times depending on the hash rate growth or fall. But at the same time, we'll achieve the goal of the difficulty bomb. So the blocks will be longer and longer, and they'll be growing ideally linearly with each block. And you still can adjust based on your main design idea of starting a particular block and having predictable time when it launches.
Yeah, so it does, there is a potential that if it goes off, the miners could rush, and then they would rush into the end of where they no longer can catch up. So it'll have the same effect as an eventual obsolescence of the chain, because no one can mine it because it's too difficult. Or blocks will be so slow that it won't be.
But we're talking here about linear growth. So with the miners, we assume the exponential growth of the hash rate. So there'll be never a time when they will not be able to catch up.
Well, there also will at some point never be a time, even if it's linear. Like if it doubles in about 15 days, which is the current algorithm, then.
So no, it doesn't matter, because the thing is, you remove from the equation entirely the hash rate from the previous blocks, which means that you leave just the linear growth, and the hash rate will be growing potentially faster than linear, even if the miners do not do anything specific. Do you expect that the hash rate growth will be extra linear?
Well, there has to be some limit to actual amount that can be done, and this is assuming that we're not working to fix it. So perhaps this is an argument for having it be exponential, so not linear growth, and having it be a percentage of the last block.
As I say, but just
Yeah.
just leaving the parameter that targets the block length and changing this parameter would be enough, and then we stay with the behavior of the function and adjusts based on the hash rate, and then we're not risking that suddenly it will be more than we planned or less than we planned. It'll be just a linear growth of the block times, which is very predictable, and something that we want to achieve.
I don't know enough about client implementation to know which one of those is easier to put into the client.
I'm not talking about client implementations at all. Sorry, I'm talking about Ethereum. The algorithm that is there, the defined algorithm for calculating the difficulty. It's taking into account the previous hash block, previous block time, and adjusts based on the previous block time. The faster the blocks are, the more of the adjustment there'll be. And I assume, if I understand properly, the algorithm proposed by you, it's a linear growth, which removes entirely the previous block time from the algorithm. Suddenly, the growth of the hash rate becomes linear. And this is risky because whatever miners do, we lose the control on adjusting the times of the blocks based on the previous block times.
To clarify, the new design isn't linear. It is an exponential curve that it just starts at a certain point, at a certain difficulty. So, and but I am curious as to the group, because in the code itself, it checks whether it's less than 10 seconds or greater than 20 seconds, and then it has an effect, and the mathematics of it is also kind of a little bit hard to parse. So is changing those variables over having a extra linear increase on hash rate over time. Is there a preference to the implementation? That for me, both of those end up in the same place. In the case that it is is a super linear, or whatever you want to call it, equation, or if you're increasing the time, they both get to the same place. So I would be curious from the client implementation side, which would be a preference. It's from the design, they're both good.
Client implementation is really such a simple thing here. It's just fine liner, the difficulty calculation. So I think we should just discuss the function itself, whether it's correct, risky, or what the outcome will be in the end. And I think that any function that removes the previous block time from the calculation, I wouldn't be happy to introduce such function to the difficulty block.
Can I get some other thoughts here, like perhaps Martin or the Besu team on preferences? Or
Yeah, so I need to ask a question first. So with the first one that you proposed, what would happen if there was a large increase in hashing power as the linear thing started? Then the linear, it would rise up a lot faster, right? Because
yes,
we would not adapt the block time. So there would be quick blocks, and the linearity would rise very quickly. Whereas with what Thomas proposes, it would adapt to the hashing power more gracefully, right? And that sounds to me like perhaps a simpler model to keep using the time instead of just block numbers. But yeah, I don't know. It sounds like it to me.
all right. I mean,
Anyone else?
some help on changing the design, I guess, on making sure I get that right is my concern. But that can be resolved.
I lost my link here. Okay, so that one that'll be more discussion offline, I'm guessing.
Yeah, well, I guess so. If is there more people that would agree with the preference that having just addressing time would be a better function here? Because I'm happy to do that. I just like to know that's the direction I should go from like the group. Like is
Yeah, I think that would be better than linear increase, like Martin mentioned. What if there's a large hash rate of miners coming in? So that would be the problem for, I think, the problem for the current design.
Basu, you have any thoughts?
None on my end. One thing I would just like to see if we're looking at these different models is like if there was a way to graph different scenarios and just kind of give a high level overview, like kind of like Martin said, what happens if there's an increase in hash rate and whatnot. I know the EF team had done that for 1559. I just shared a link in the chat here. Something similar to that, I think would be valuable also as we're discussing this with the community to see like, hey, this is the current bomb. Here's why it's bad. Here's this different proposal. Here's what happens if the hash rate increases, decreases. The kind of basic edge cases.
Yeah, but I think one thing that I think would be illuminating, the way I see it, these two different things that we're discussing right now, is that in one proposal you have block numbers on the x-axis, and on the other proposal you have calendar on the x-axis. And I think do we prefer linearity, a graph with time on the x-axis, or do we want linearity on the graph with block numbers on the x-axis? And that, I think, is a key difference between what we're discussing right now.
Thomas, what would you respond for that?
I understand the problem, but I don't know how exactly. I'm just trying to find the plot that you're using, whether there was time or block number on the x-axis. Generally, I think that what we want to have is more or less we want to target those axes, like those two approaches to be equal. So like the growth of time is more or less similar to the growth of the block number on average. And then through the difficulty bump, you actually want them to start diverging. So they over time, while the time is expected to be stable, the block number will be expanding. And then the plotting would be with the time would be better with the growth of the more or less, I would like to have the block time on the y-axis and the time on the x-axis and show how the difficulty bump would cause this particular chart to behave. So I want the difficulty bump change, if we decide to change it, because it's not like I really need this change, then I would like the block times to keep growing. And then we want to see different scenarios, whether we assume the linear growth of the block time or the exponential growth of the block time, or like step by step as it was in the past, like exponential with steps. These are the functions that I would like to look at. And then I would like to adjust the difficulty calculation function to lead us to one of those preferred scenarios. So I see Martin's point in like mentioning how we would like to chart it and how we would like to discuss it.
So I'll work on charting, and so we can have a better discussion about it, and then we'll have that be done offline. So that's all for that, Hudson.
Okay, sounds good. Next up, we have the time-based updates, EIP 2456. That's the one that Dano did, and then I forgot who took up on that, if anyone.
I can take over for this one.
Okay.
So Jace, we had 2 calls ago. Jason Carver was on, and we talked a little bit about this, and we arrived at a. This is my read of the group, and if I'm wrong on this, please correct me. But it seemed like if we could do time-based forks, that would be preferable. The issue is if we do it with the current uncle rules, then we have to have a look back function for it to be safe, and that's not preferential for due to client developer user experience, and then also user experience for contract developers. To fix and the other option is to fix the uncle rules, and so that you can have just a time and not have to have a look back function, but that seems to be possible yet complicated. And so the what's left for that EIP, one, we'll need someone to champion moving it forward, and two, understand, is it desirable enough from the community or the people that would want it that it's worth the trouble of putting in? And I don't know the best way to answer that last question. That's kind of the status of that EIP.
Is anyone championing it?
Not at this point.
Okay. I think it should be dropped off from discussion if no one's championing it, since that's one of the requirements for something like this to move forward in the first place, and otherwise it's just going to slow down chat.
Yeah, I agree. We seem to be discussing this every 2 weeks and not really making any approach, just having the same back and forth.
Yeah, I'd say yeah. If someone wants to be a champion on this, feel free. You would talk to James, me, and Dano about it, or really either one of us three, and we would connect you where you need to go to be the new champion on it. Next is EIP 2046, reduced gas costs for static calls made to precompiles. And the last time we talked about this, we had we were talking about how we can how this measurement has been done in Open Ethereum and was found to be safe to reduce those costs, but that it would need to be looked at on different machines on different machines and different clients, if I remember correctly. And then there was a lot of discussion on, we can lower these other precompile costs, and we can raise these other costs. So I don't know if we concluded anything last time that was like a substantial next step, other than to say that the Blake 2 cost is higher than Ketchak, and that would be discussed offline. I'm not sure if anyone took up on that or not. And also that improving gas cost of Blake 2 may help the move to stateless Ethereum. I don't think we had anyone who could confirm that last call. So this is just going over what was discussed last call about it. I think this is Axic's EIP, and he's championing it. Am I right? Or is someone else doing that, Alex?
Sorry, only caught my name. I
Sure.
guess you're talking about 2046?
Yeah, basically saying, are you the champion currently of this EIP, and are there any updates to it from your end, from any discussions you've had?
Yeah, probably I'm a bit champion of it. And Alex Vlasov has done quite a few benchmarking steps. We discussed it on the last call, but I think neither of us have done. I mean, in the last Orco Devs 2 weeks ago, but I don't think neither of us have done anything to incorporate those results into the EIP.
Okay.
I think that's the status.
Yeah.
We probably still don't have like a final idea what would be a good proposed value. What Alex did was benchmarking the precompiles to make sure that none of them would be a risk if we were to reprice the static call. And the finding he had is that 2 precompiles, if I recall correctly, EC Mul or EC Ed, and some, I think these 2 are slightly underpriced, so they would need to be increased.
Martin, did you have something?
Yeah, I think I took it upon myself to do corresponding benchmarking for Geth, and I haven't not had time to do so. So no progress there.
Okay, that sounds good. So when we
Yeah,
talk
I
about,
guess.
oh, go
Yeah,
ahead,
I just
Tim.
wanted to ask Alex. We also had doing these benchmarks for Besu kind of on our to-do list. I just want to make sure we didn't get to it, but just want to make sure it's still a valuable thing for you.
You asking me or Alex Vlasov?
You. I mean,
Um,
either, right? But you were speaking about it just recently.
yeah, I mean, I
But Tim,
personally.
isn't it mainly for you as a node implementer? It's valuable to you to have those to make sure that your node will be able to keep up regardless of what prices are set.
Yes, sorry, and I guess on the last call there was a discussion of maybe lowering the prices even more, and I was just wondering how those I guess ideas were moving along. Like, well, obviously once we implement it, we'll want to benchmark and make sure that it works. But is it valuable if we say benchmark and try to find what's the lowest possible price that works, and that's and bring that back into the EAP? Yeah.
Well, if I may add a little, I started writing much more radical proposal in a sense that we should really reprice all the precompiles by like having more thorough approach to it, and also be more restrictive what would be performance differences between different clients. Just because, for example, an implementation in which is used by Open Ethereum is just very slow compared to everything which exists for last 2 years, starting from the work of Zcash and now implementations of 1962. And there I wanted to include the proposals that we actually make call to the precompile to be 0 and always absorb the cost of doing the gas estimation into the precompile cost itself. So it would basically increase constant contributions, but we will now pay a reasonable price for what precompile actually does. And this potentially will make Blake viable. And there will be also changes to catch up precompile to better reflect its internal structure. That it actually doesn't make any difference between 0 and 128 bytes. But I'm not done with the spec yet.
I really like that idea of doing a broad sweep of all the precompiles and seeing what can be adjusted to make it more efficient in clients, to more, not efficient, well, I guess efficient, but also as like fast as possible in clients. Any other comments on that? At this point, I think for this one, we'll talk about Berlin timing in a second, but it doesn't sound like there's any. We're kind of just still doing some measurements right now, and then this new EIP is being developed by Alex Vlasov. So that is the latest for that one. So
So
any
that's
other?
no, that yeah, that's totally unrelated. I mean that doesn't have anything to do with this particular EP, which is under discussion.
Well, yeah, it doesn't have anything to do specifically, but if he does one that's like would supersede it, then that would be something that could make sense.
Yeah.
Okay, so the clients just need to do more tests or the measurements. That sounds good. So that's all for EFI. James, do you want to go over Berlin timing?
Yes, we're pretty close to. I'd like kind of a good estimate of what the implementation would in the integration time it would take to get the BLS EIP done, because it sounds like that's the one that would take the most work at this point. Is there a sense for how long that would actually take from the clients? Like, is this something we could say it will be done in 4 weeks, and then we can have a test net running for 4 weeks, and then we can hit go on the fork.
Yeah, I don't know what Peter says. I would say no sooner. It cannot be integrated before anytime sooner than 4 weeks. What would you say, Peter? I mean, yeah.
Are we talking about single EIP or
A single EIP with 9 precompiles. BLS 38012, BLS 12381 curve operations.
So I probably missed something, but our current timeline is based on just having 2 EIPs in Berlin, right? The BLS one and simple subroutine.
That and possibly the difficulty bomb one if it is simple enough to have in, but it's not something that we should push back anything for. So those 2 plus maybe the difficulty bomb one.
And I think it'd be better. So, from what Alex Vlasov said, there is a Go implementation and a Rust implementation, but it hasn't been closely looked at by the client implementers. It's just been implemented outside of the core client implementer team. Is that accurate?
Yeah.
Okay. So if that's the case, then until they look at it, I don't know if there's going to be a good estimate, is my guess, for that one. For simple subroutines, that's something that they have been, or that most clients have been implementing or have implemented. And we talked about that earlier, and I think most people said it was on its way to being implemented, and it wasn't too bad, right?
Yep.
Okay. So rather than say how long, let's do the list of priorities like we did last time and just say that the BLS 12381 curve operations should be a priority, unless someone disagrees, so that we can, by next time, have a better idea of Berlin timing and we don't kick the can down the road. Anybody opposed to that or have any comments or alternative ideas?
Maybe just like highlighting both the EAPs, like if I guess clients can look at 2315 and 20 and the BLS one, and yeah, try to get the implementation started if possible, and then in 2 weeks we'll have a feeling for how far along they are.
Yeah, I think that's the best we can do today, in my opinion. Anybody have a different opinion? How does that sound, James? This is kind of your
Well,
call.
no, that sounds great to me.
Cool. All right. Unless there's anything else, we'll move on to item number 4. This is EIP 2565, repricing of the EIP 198 ModExp precompile. And I believe that was.
Before we do that, should we just say out loud the process point for the time-based one so that can be recorded? Because
Yes.
it came up a lot because it was on the
yeah.
Berlin list.
Sorry,
So
I forgot which EIP that was. Okay, you were talking about the thing we talked about in chat, right? On
yes.
Zoom. Okay, yeah. So you can go ahead for the record.
Yeah. So it's come up because it's on the Berlin list. Without a champion, it doesn't make sense to move it. So I'm moving to remove that from the Berlin list, but keep it remain it as EFI with a tag for request for champion, and we'll see if someone shows up. But until then, we don't need to talk about it on this call. So I'd motion for that.
Yeah, sounds good to me. And if there isn't a champion, this is something that the EIPIP meetings can look at for the process flow of something being made into EFI and then losing a champion, because we don't have a process flow for that right now. Okay. Going back to EIP 2565, repricing of ModExp precompile. That's Kelly, I believe.
Hey everyone. Yeah, so I just wanted to take a few minutes to introduce the EIP 2565. As Hudson mentioned, it is a repricing of the ModExp precompile, which is EIP 198. EIP 198 was introduced a couple years back by Vitalik for modular exponentiation operations, which are sort of a foundational arithmetic operation for a variety of cryptographic operations. I believe Vitalik introduced it for RSA signature verification. We've been using it for VDF proof verification, and it's also relevant for things like snarks and accumulators and a variety of sort of other cryptographic operations. As we started using this, I'll just share my screen here shortly. What we saw is that the pricing of this EIP, which you'll see these blue dots here, was significantly more expensive than some of these other precompiles, on the order of sort of hundreds of millions of gas per second. Whereas other precompiles, most recently the Blake 2, EC Recover, are all sort of in this 20 to 30 million gas per second range. And so sort of the core of this proposal is to change a single parameter in the pricing formula in EIP 198 from a value of 20 to 200. And what that would do is it would shift this sort of blue curve here to pricing in line with this yellow curve now. So we get about a 10x reduction in the cost per operation. And it still remains sort of more expensive than some of these other things like the Blake precompile and EC Recover, but provide sort of good practical savings for this precompile with very minimal implementation changes. So basically just changing this parameter from 20 to 200. We did explore other ways to improve the efficiency of this precompile. So one of the things that you can also see if you look at this is that we did devise a more accurate pricing algorithm, which can sort of be seen here for different input values into the precompile versus the existing one. So you can see we have an R squared of like 90% versus 20%. And this is because this new algorithm better relates to sort of how the limb-based arithmetic is done in big integer libraries. Currently, we're not recommending making this pricing change because it is, I guess, maybe has a higher implementation cost than just changing that parameter. Although it's certainly something that we're open to and wanted to get some feedback from folks on. And then finally, I guess the last thing I'll say is we did also look at the efficiency of sort of this precompile and the library that's used today versus some other big integer arithmetic libraries. There are further gains, again, here by switching out this underlying library. But again, this is not something that we're recommending at this point because it has additional implementation complexity. So the overall summary is basically what we'd like to do is change a single parameter in this in the EIP 198 pricing formula from 20 to 200, which will bring the pricing closer in line to some of the other precompiles, which are around this 30 million gas per second.
I have a question.
Sure.
So those benchmarks that you did, what was the underlying implementation that you measured against?
Yeah, this is using the existing Geth implementation. So these are all, yes, these are all using Geth.
Because on old benchmarks, we did see that ModExp could be like cut in half at least on Geth, but parity was actually already underpriced. And there was a note that they did the exponentiation by squaring, plan to optimize it. I have no idea if they've done so or if there's still the exponentiation by squaring. So yeah, I don't know how if these benchmarks that you have charted out in the EIP are actually sustainable on parity.
Yeah, it's a great question, Martin. It is something that we looked into. We haven't run those benchmarks yet. We did notice though that since since this EIP was implemented, I believe that there were some changes to this precompile. I'm not sure if that was the underlying library or maybe there were more cosmetic changes, but we did see that at least there were some commits against sort of this precompile in the code base. So I think we could certainly look at it for parity as well to see sort of what they have and what their benchmarks look like.
Even while I don't work in Parity Client, I looked at their implementations before. And the problem there, at least before, was that they use the native big integer library, which is kind of standard Rust library for this. And internally, this library uses 32-bit limbs instead of 64 on modern processors, which makes it highly inefficient. While Guess uses native Go library provided by Google, which uses optimal limb sizes. So I think simple update of the underlying library would be sufficient for parity. Just bump the version.
Yeah, thanks, Alex. That's great feedback, and I think we'd be happy to take a look at parity and either run the benchmark or come back and provide any updates on that if folks would like. As sort of shown here, there's a variety of other benchmarks that could be used, like or other libraries that could be used, like GMP or OpenSSL. So I suspect that similarly for parity, there are those. Hopefully their library is already efficient enough to sort of absorb this gas reduction, but that's something that we can add into the EIP is a benchmark on parity.
So just to point out something, so probably if you start using OpenSSL and stuff like that, the reason they will be a lot faster is because they will probably use all kinds of SIMD, SSAE, AVX, etc. instructions, which as far as I know, Go does not use. But the downside is that you are pulling in a big soup of C code, and also you're losing a bit of portability. So for example, if so the standard way of using, for example, OpenSSL is that you have OpenSSL installed and use it as a shared library, which means that everybody is fine. So if I have AVX, then great, my OpenSSL will be faster. If you don't have, then yours will be slower. But Go does static linking. So if we build Geth on some machine which has AVX, and then you try to run it on a machine which doesn't have it, then it will blow up. And if you do it the other way around, then you just lose the performance. So you start introducing these kinds of strange build time constraints.
Right. Yeah. No, it's a great point. I mean, I think just to reiterate, our hope is that as we go benchmark parity, that right now at least the repricing doesn't require any change of the library under Geth, right? So with no sort of underlying library change or pricing algorithm change, it still stays sort of in line with the pricing of other precompiles. I think our hope is that we'll see the same thing for parity. So as Alex mentioned, maybe there's a simple version bump. Maybe the parity library is already using an improved library from the versus the original benchmarks. We certainly saw in the case of Geth, it got about 2x better, and these are just from underlying improvements in the Go big int library, essentially mass/big, which I think is what Geth is using now. So it's highly likely that parity has also seen similar improvements, and so I guess at least at this point, maybe the action item is to benchmark this for parity and to see if they're in terms of speed are on par with Geth. And if so, then the recommendation is just make this very simple parameter change from 20 to 200 and not change the pricing formula or underlying libraries. Okay, great. I mean, unless there are any other questions, I think that's it. So I think, maybe just to reiterate next steps, we'll take a look at, we'll go and run the benchmarks for parity for the test vectors that are there. And then we will take a look at what that implies from the sort of a gas per second for parity. Ultimately our goal is to keep this precompile, ensure that this precompile is more expensive than sort of the other precompiles, right? So we're not trying to move this down below like pricing of EC Recover or the Blake 2 precompile. And if we can achieve that with this this simple parameter change, then that's what we'll be advocating for.
All right, awesome. One last question, and you might have said this and I just missed it, but this repricing, what is the ultimate goal of this as far as like use case goes?
Yeah, sure. So modular exponentiation is sort of used in a variety of cryptographic operations. So verifying RSA signatures, verifying verifiable delay function proofs, accumulators, RSA accumulators as sort of a replacement versus like Merkle roots or something like that, verifying snarks. So there's really sort of a broad number of cryptographic operations that will benefit from this repricing.
Okay, awesome. Anybody else have any comments?
I just want to say that's a great justification, and this is what we'll have to say for every single EIP. It's kind of few sentences that tell us why we change things, and also give the community the overview of why we're implementing things.
Thanks, appreciate it. And thanks for the feedback, everyone.
We should save it for the EIP IP meeting.
Yeah, actually, Kelly, where's that posted?
This EIP, it is just under the eips.ethereum.org.
Oh, I meant the document you just displayed on the shared screen.
Oh yeah, that is the EIP actually. So I just pasted it in the Zoom link here.
Oh, okay. Sorry, I thought it was like a PDF or something. Okay, cool. Next up, we have EIP 2602, disable null hash message verification for EC recover precompile. And I forgot. Oh, that was Wei.
Yeah. So this is actually quite like a really simple EIP. So the background is we have the EC recover precompile, and that precompile basically does signature verification on the SIP256K1 curve. So the thing is we also just learned like last week on this. So the thing is the precompile we have is actually pretty low level, and it allows the user to directly pass any hash they want. And it turned out if you pass a new hash, which is basically just 0.0000000, then it turned out in this case the signature can be forged. So it's not safe to use EC recovery in this case at all. The actual like crypto thing is actually that if you use the EC recover without a proper hash function, then the whole thing is just basically unsafe. So with the proper hash function, there's nearly zero chance you get no hash. But if the contracts are doing something weird and just happen to have a new hash, then this thing becomes unsafe. So the EIP actually just proposed to just disable verification for new hash like idle. So when the message hash we enter this EC recover precompile, when the message hash is new hash, then we basically then we just return false. Just do the same thing as when the EC recover receive an invalid signature. So yeah, so that's basically so there's nearly zero valid use case for new hash at all, and it's actually possible that some contract might have misused that because I mean, for the precompile, the default parameter is new hash. So if the contract forgot to pass the message in some cases, then they can get into this trap. And we actually found one or two contracts on the Goli testnet that tries to validate a valid signature against a new hash message. So that's entirely unsafe. yeah, and yeah, so I think is indeed the case that this is a easy recover function is a pretty low level function. It doesn't specify the hash at all, but I just think it's good if we can encourage those safe by default constructs on Ethereum. So just disable those unsafe things, especially those unsafe things that has no valid use case in the blockchain. Yeah, so yeah, that's a basic introduction about this EIP.
Sounds good.
Anybody have comments or questions about this EIP intro?
Makes sense,
Well,
but
there
great.
exists a trick which could be potentially usable or used by some contracts already. I just was looking for a link for it. It's now in a chat. So if you just disable using the zero message hash, it can become invalid. I think that this is up to implementer. If you don't like, it should be posted as a security vulnerability, and contract developers either should upgrade or should never should put in explicit requirements to not have zero hash if they actually want to verify the signature, and not to use any hacks around it. But forbidding it right now may affect properly working contracts which actually wanted to use this.
I wanted to raise exactly the same thing that Alex mentioned about the existing contracts, but if we can confirm that this is not the case, if there are no contracts that do that now, then maybe it's worth to fix it the way Wei suggests.
Can you explain more? So the valid use case of new hash.
Well, this trick was posted by Vitalik a lot of time ago.
Alex, you're breaking up.
Sorry, I cannot do anything with my internet connection, but if it doesn't improve, just
Yeah, it's still not improving.
Okay, let me try to reconnect.
Was anyone else going to speak upon Wei's question?
Thomas, can you expand on it?
Which Alex?
Martin, I think Alex posted a link in the chat that mentions one of the use cases that Vitalik was suggesting on its research.
Yeah, I'm
Right.
taking a look. So, I, from my understanding, this looks to be a way to get cheaper gas price for the EC add or EC new operations, like by abusing the EC recover. So something like that, from my understanding.
Well, it was a trick posted by Vitalik to not abuse, to not get cheaper operation. I mean, you could always write elliptic curve point multiplication or addition as solidity contract, and then yes, it will become expensive. But there was no any form of precompile which allowed you to do curve operations over SIG-P curve. So this was a clever trick how you could abuse it to get the multiplication function, and addition function was kind of cheap. You could implement it in Solidity. So I don't know of any solid example who uses this, but since it's an old trick, maybe someone does. But I don't think there is any way how you can verify that no one does use this trick. It should be considered more a precompile vulnerability than, not the precompile, the particular contract vulnerability than in principle the precompile vulnerability.
Okay, anybody else have any comments?
Well, you can check. You can check if it's used by implementing the check in the code and then sync the blockchain from the beginning.
Yeah, I remember we didn't like this one was actually due to consensus issue like we had on Open Ethereum master branch. So the upstream did an update. So the ICCP 256K1 library did an update. The Rust library did an update, and they added this new hash message tag, and we sort of missed that for a while. So during that time, I don't think we broke the mainnet, but we did find like one or two contracts on the blockchain in the Goalie testnet. So I still don't know what they are doing, or are they using this trick, or is it's actually like trying to actually verify a new hash message. Yeah, but I'm not sure about that either. But yeah, so the thing is we had new hash message in Goalie testnet, but I don't think we found any on the mainnet yet, like at least from our knowledge.
Okay, anybody else? All right. Next up, we have EIP 2583, penalty for account try misses. That's Martin.
Yes. So I talked about this 2 weeks ago. The idea has been expanded a bit with some alternatives. And in general, I'm curious to hear if any of the developers feel that have taken a look at this and have any thoughts about whether it's worth pursuing. I personally believe that it most definitely is as a denial of service protection. Yeah. So, people, please, do you have any opinions about this?
Yeah, I was looking at it, and it's an interesting step to take in exploration also on our research on stateless client and charging for the tree access on witness generation. So even if we in the end don't implement it in the form as it's suggested, it's definitely worth exploring and even playing with it and checking what the outcome is.
If you just said it's good for stateless Ethereum, is there coordination being done with the stateless Ethereum team on this, or is this something that wouldn't be applicable?
It's been, yeah, I've discussed it a bit in the stateless context.
Okay, cool.
However,
The first
yeah,
time
I
I've seen
think
it was from Martin's message on the stateless Ethereum channel. Sorry, Martin, for interrupting. Go on.
no problem. No, I was going to say that I see it as something that should be implemented kind of as soon as possible on mainnet, because there's a pressing need for it. Whereas for stateless, it's more of a research project that can be taken one step at a time. And I'm not sure if there, I mean, I think there's a pressing need for it, and I'm not sure if there's enough time or interest from the. I think people who are working on data stuff have 100 problems that are going to be solved eventually, and this is maybe priority number 95. I don't
Okay,
know.
that helps me understand it a lot more. Thank you.
Whereas from my perspective, it's like one of the most pressing problems on mainnet right now.
Anybody else?
I'm definitely in favor of this one. So it's a good thing to understand. I just mentioned that it will be also a great addition for stateless Ethereum, but obviously the timelines in the research group are totally different. So
Yeah. Away from parity, do you guys have any thoughts about this proposal? Or anyone from Open Ethereum?
Not really. I mean, it's not hard for us to implement, so we are fine.
Martin, is this something that I know last time we talked you didn't want to move to EFI yet? Is this something you'd want to try to move to EFI with today, or does it need to be cleaned up more?
It doesn't need to be cleaned up more, but I think it needs to be get more input from developers. There are two variants. So the initial proposal has a flaw that makes it if you put the penalty above around 700 or 800, it can be bypassed. So there's no point in doing that. Whereas there are two alternatives here, which changes the side effects a bit, but also makes it possible to set an arbitrary high penalty. Yeah, but they have different downsides because they break backwards compatibility in different ways. Yeah, so I think we should have some more. I just want some more discussion on that, and not necessarily deciding on EFI or not right now.
Okay, that sounds good. Anybody else? Okay, we have about a minute left. I think that gives us enough time for Dimitri to do a quick testing update. Dimitri, if you want to go ahead.
Oh yeah, 1 minute. So we've been discussing a new approach that we could take on testing. And with the Go team, there was a proposal
Oh, you're cutting out, Dimitri. We can't hear you anymore.
to implement a system of transaction and generate a state tree hash and some other. This is an idea, it's a concept. I can send you a link for discussion, and we think to implement it with the Go team. So they say they can support this approach, and they think that having a tool that can produce a state transition can be useful and easy to implement on client devs. So we are just try to do it and see how it goes. And I would like to hear feedback from other client developers on what do they think about this approach and how difficult it would be to support for them eventually. Yeah. And I'm sending a link right now in chat.
Great. If you could write that all up in chat because you cut out a couple of times. So post the link and write it up. You cut out enough that just rehashing that over text is going to be a great idea.
Okay, I sent a link to chat. So there's a discussion. I invite developers to discuss this and send some feedback how difficult for them it would be to implement.
Okay. Thanks so much. We are out of time. Do the EIP-IP survey, please, if you haven't done so. We really want a good amount of core developers and EIP editors to do it, but also anybody who's ever looked at an EIP can do it. So I'm posting that in Gitter, I'm posting that in YouTube chat, and I'll probably post it to Twitter once again. So please participate in that if you haven't already, and we will see you all in 2 weeks on May. Oh, go ahead.
Point of process, did EIP 2565, the repricing of the ModExp, go into EFI, or is that something we should do next week?
Next week at minimum, because it just got introduced.
All right.
Perfect.
And Hudson? No discussion. I'd just like people to know that I've taken over as champion for the Prague POW proposal.
Okay,
with Christie.
That sounds great. You said with Christie or of Christie's proposal?
With Christie's blessing, I am
okay, it cut
taking
out.
over champion.
Okay. Great. We will talk to you all on May the 1st at 1400 UTC in 2 weeks. Thanks, everyone. Goodbye.
Thank you, Hudson. Bye.
Thank you. Bye.
Cheers, all.